And welcome, ladies and gentlemen. We're looking at properties of logarithms, page 615. And this particular problem is asking us to evaluate log base 3 of 108 given these previous two facts. So the question for us is, can I rewrite 108 as some product of 2's and 7's? Peculiar. I have no idea. Well, let me try to break it down, actually. Let me actually break it down this way first. Let's do 108. 2 goes into it 54 times. 2 goes into that. What's that? 20. Well, 5 plus 2, 7 times? Wait a minute. What am I doing wrong? Right? Wait a minute. But then, wait, did they give us another fact? Because we needed a... Oh! Aha! We do technically have another fact. We know all of the logs of the powers of 3. So, this is the same as 3 times 9 and 3 times 3. Aha, okay. I was like, if that was 28, that'd be a power, right? Or a multiple of 7 anyway. So this is the same as 2 to the second times 3 to the third. Okay? So that means log base 3 of 2 to the second times 3 to the third. I can break that up. The log of a product is the same as the sum of 2 logs. So that's an ugly 3. So log base 3 of 2 squared plus log base 3 of 3 cubed. Man, look at that. That's just like 3 is what I imagine that would be, like just singing it higher and higher pitched. I don't know. What do you guys think? And then I can use the power property of logarithms, and I can whoosh. Actually, let me whoosh. There we go. And whoosh. Take those out front, right? So I can write that as 2 times log base 3 of 2 plus 3 times log base 3 of 3. And like I said, even though they didn't give us a fact for log base 3 of 3, we should know what log base 3 of 3 is, right? Right? So this is the same as 2 times 0.6310 plus 3 times, what is log base 3 of 3? What's that ask us?
3 to what power is 3?
Yeah, 3 to what power is equal to 3, so that's 1, the first power. So this is equal to 1.262 plus 3 times 1 is 3, so looks like 4.2620 is the answer. That was O. Alright, so that was just kind of doing some manipulation to some previously known logarithmic values to discover the value of a new one. So interesting stuff, nonetheless. We're going to use some of those properties a little bit later today as well. How about one of these solve each equation?
Yeah, 29 to 35.
29? I'll do 29. I might have time for a couple. We'll see what we can do. 29 for you. Here we go. 29. I don't know. That was a pretty good song. I'm proud of it. Feel free to add that to dubstep and like electronify my voice. Here we go. Oh wait, why am I just writing that all out again? The first thing I should do is deal with these powers. I'm trying to, okay, general outline. I want to write each side as a single logarithm. The left-hand side is already a single logarithm. The right-hand side, I'm going to have to combine. So that's going to be log of 16 to the 1/4 plus log of 49 to the 1/2. Now notice that if I don't write the base 10, we're cool with that because it is implied to be base 10. So we can have that shorthand. So log of the 16 to the 1/4 power, that's the same as what? What does 16 to the 1/4 power mean?
The fourth root.
The fourth root of 16, which is 2. Plus log of 49 to the 1/2, what does 1/2 power mean? Square root of 49 is 7. So I've got log of 2 plus log of 7. The sum of 2 logs is the same as the log of the product of their insides. So I'm going to have log of 14, right, is equal to log y, logi. I imagine, like, if you called Logan, the dude from X-Men, like, if you called him Logie, I imagine he'd, like, stab you with his, like, crazy blade hands, because he's Wolverine. What's the name of the metal that he's got? Starts with an A.
Riley is also a fairy tale.
Interesting. Huh. What is the name of the metal? It starts with an A, I think. It'll come back to us.
Isn't it the same thing that Captain America's shield is made out of?
Oh, maybe. According to the new fiction, perhaps. I can't recall.
Yeah.
But anyways,
Aluminum.
no, it's like some fictional metal.
Yeah.
Did you know that the Australians and the British pronounce aluminum as aluminium? Isn't that great? Also, the Australians, if they were to talk about like a region of space where you're in the sticks, like, you know, like if you're far out from civilization, they call it whoop whoop. Like, so like we live in whoop whoop because we're far away from like big society.
That's great.
We're out in a rural area.
Sweet.
Whoop whoop. So anyways, there you go. Adamantium. There we go. Adamantium claws. Wow, see, I just had to talk about crazy other stuff for a minute, and then my brain is able to find stuff. It was like I was just dredging knowledge from my brain, and eventually it came up out of the mix. But anyways, I get y equals 14. Does 14 work in the original equation? Yes, because it'd be log of a positive. We're fine with that. Maybe one other question, non-whoop-whoop related. Do we have another one here?
Anyone confused with 35?
35.
35.
That won't work for everyone.
Oh, that's got like triple log that's being combined. A tactic that the Finns used when defending their homeland from the Russians as tanks and whatnot would be coming down the logging roads, these narrow roads through the forests of Finland. They would have these cross-country ski teams with rifles, and they called it like cutting up the logs is what they would do. And they would actually like go through and like ambush and just come through the forest and like shoot some dudes and like demolish one tank, and then it would like stop the whole line, and then they'd demolish another tank a little way down. So like that group of units can't retreat, and they'd be caught, and then it'd just be like cross-country skiing around, taking them out. Yeah. And that's why I think, I don't know if that's the origins of the biathlon, but biathlon is, as you guys of course know, is not running and biking or swimming and punching. It's skiing and shooting. Yeah, right. Who would have thought those two sports would have gotten the right to be a biathlon? What's a monoathlon?
Just running.
Just running. Any sport by itself. I don't know. That's pretty good. Huh. Anyways. Okay. So let's see. I don't have any power tricks I have to do here, but I've got the difference of two logs and the sum of two logs. So difference of two logs is the same as the log of their quotient, right? Plus log base 3 of 2. And then the sum of two logs is the same as the log of their product. So that's log base 3 of this thing. Actually, I'm going to multiply by the reciprocal here, if you're cool with that. 3/8, and then multiply by 2 equals the log base 3 of 4r. And let's multiply that out. So log base 3 of 64 divided by 8 is 8. 8 times 3 is 24, times 2 is 48, right? So that had a little bit of a stack rack situation almost. And now I've got two logs equal to each other. Their base is the same, so therefore their insides are identical as well. In another class yesterday, we discussed the possibility of what if you had two genetically identical twins marry sisters who are also two genetically identical twins that they're
We have
offspring.
this question for like 3 months.
Really?
And I posted it on Tumblr. No one's answered no.
that genetically the dice roll of their offspring would be identical.
Exactly the same.
No, because like my wife and I have had 2 sons and they don't look exactly the same
But,
because it's a new mix of DNA every time.
That's what I was thinking.
But there's still they would be indecipherable from siblings on a genetic level. I
Yeah, but
imagine.
like legally they'd be cousins, but genetically they'd be siblings,
Right.
which is really cool.
Yeah, it's interesting.
Weird. What?
I don't think that.
Well, I don't
Yeah.
No, really don't, because like if you got an
Yeah.
identical set of twins and another identical set of twins, and they have
See.
children,
We're good.
genetically they'd be siblings, but legally they'd be cousins.
Oh yeah, because they're like the same.
Yeah.
Because they're married into like the same
Ew.
family.
I don't follow.
Anyways,
Just like
internet.
the red ones.
We'll talk to you later, internet. This conversation's going to continue here for a minute.